Hello, now I'm going to show my demo of time series without exogenous variables using pycaret. The first command is used because we need to only focus on the essential messages and small warning can be ignored so that the output is clear. In the second one, we installed pycaret using pip install pycaret and some other libraries as well. And we loaded, I took the data from Kaggle airpassengers.csv and forecasting horizon and folds. So we define the horizon FH as 12. So that means we want to indicate that we would like to predict the next 12 months. We also set the cross validation fold to 3. Next, we set the global figure settings to s- look how our plots will be appeared in this notebook. And as we can see, we use TS forecasting experiment. That the setup method also prepares the experiment specifying our data and the target variable passengers in other metrics, and we can see it returns some metrics about the data and also pre-processing. And now we can see some plots, plot of the time series data. uh, we can observe the data trends from this. And the next plot, uh, we understand the level of pre-processing we have done. And ACF, coming to the ACF plots, uh, this is used for determining the order of the time series models. And ACF and both ACF and PACF are used to understand the correlations for determining the order of our time series models. And coming to the periodogram, which helps in identifying trends and seasonality in the data set. And same goes with diagnostics. Here we can see different types of plots for better visualization. And coming to the decompositions, uh, we do this to analyze the trends, seasonality, and some other residual components of our time series. So the train test split model, uh, we use this plot to understand how our data is divided for training and testing, typically 80 is to 20. Cross validation. Here the blue dots represent the training data and oranges represent the validation data. So this helps us in model evaluation. Uh, Next is summary statistics. We just use the basic functions check stats to view the summary statistics, which provides us some model insights of model performance. Stationary tests, we conduct these. It is an important metric for time series analysis. And white noise, we do the junk box test, if whether to see if it is if there is any correlation or not. And experiment.checkstats, we can see all the statistics, summary, white noise, stationarity, normality. And this is the part one of it. And coming to the part two, and in the part two, So same, install pycaret and other dependencies, getting the data, defining the folds, and importing the class and setting up the environment using setup function, adding the data and defining the target variable, and it gave us some metrics about it. Now experiment.models, it gives us all the models that can be useful for this, all the estimators useful for this. Experiment.setup, they used object oriented API for this. Both the setups are the same. And model experiment.create model, here we use the ARIMA model for this. We specify the order and the seasonal order as well, and then we can make the predictions with predict model. Next, we evaluate our model. We can plot our diagnostics to check its performance. We can just check the estimator given the model, can check the actual versus out of sample forecast of passengers. The black ones represent the original one. The light blue represent prediction intervals of ARIMA and the forecasted results, and the dark blue represent forecasted results of ARIMA. And the statistics, we can get the statistics using check stats of all summary, white noise, stationarity, normality. And we are plotting different types of plots, plot diagnostics, where we can see all the ACF, PACF, ARIMA residuals, periodograms, etc. We are plotting the in sample plot here, which shows us the actual versus forecasted sample of the passengers versus what ARIMA has predicted. And experimented plot model of decomposition and decomp STL model residuals for a period of 12 months. We can tune this model for to improve its performance as well. So what we take a model called like GBM CDS DT and predict it with our data and give its metric, and we can get its metrics, the error performance of it, actual versus forecasted of this new LGBM regressor. Yeah, as we told, we can tune this model for better performance. And as we can see, it the prediction has been okay with the LGBM regressor model. Now we can save this model and plot it as well with our own uh, defined baseline or tuned labels as well. And we can see here the plot of the final model of the tuned one. And we can see its predictions here for each month, and the final model versus the tuned model. And as the predictions are very good, we can just save this model. And if you want to load this transformation pipeline, we can just use the load model function, and experiment load.predict model gives us the predictions. Experiment.plot model of the final model with the parameters fh36 gives us its predictions. And we will go to the third part. Okay. So same, installing pycaret, and then we load the air passengers data set. We specify the same forecasting horizon and number of folds cross for cross validation, that is 3. Import the class TS forecasting experiment. We compare the and we get the metrics. I mean, before after importing the class, we can see uh, we created a session using the setup function which takes the data and target variable and fh and folds as well defined previously, and it returns some metrics and as well as reprocessing stuff. Now we compare the baseline models using compare models function. I selected the top 3, and metrics.exp.pull, it basically returns a data frame of the metrics, and now we calculate the uh, no, first we tune the selected models to the top 3 models to optimize their performance. Now we calculate the top metrics and determine the weights for a blending task. And we blend the tune models using the weights with the function blend models, which takes the tune model and the method and the weights, and then predict it with the blender with the predict model function, and we can see its performance of ensemble forecaster, actual versus forecasted, and another plot for the same finalized model. And after this prediction is done, we can just save the model and use just that get data to of index to get the different types of data sets of pycaret for different tasks like multivariate regression, NLP classification, clustering, binary classification, anomaly, association rule mining, regression, etc. And finally, we load the saved model, sorry, that transformation pipeline using the load model function. And this is my demo of time series without exogenous variables in 3 parts. Thank you. Using pycaret.